Okay, so in this video, this is our second video of day 5, unit 1 in geometry. We're just going to finalize some things about vertical angles. So these three theorems or axioms, right, we saw in the first video already. We already know that opposite angles are going to be congruent. So for example, angle AIC, try to make that not look like a less than symbol. But AIC and BID are absolutely congruent, right? And we can say the same thing about CIB and AID, right? Opposite angles will always be congruent. Okay, now right here, adjacent angles are going to be supplementary. So this also is axiomatic. So that just means, angle AIC plus angle CIB are going to always equal 180 degrees, right? And real fast, let's touch on something that I didn't really touch on in the first video. Adjacent means near or next to, just FYI. Okay, adjacent is near, if I can spell, near or next to. Okay, so let's keep that in mind. And linear pairs are supplementary. Okay, so adjacent angles, linear pairs, kind of sort of one and the same. Um, Now, when we think linear pairs, I'll just go ahead and kind of illustrate. A linear pair would be not necessarily, not in the conventional sense, what we call a line and a transversal, but it's the same idea. So this right here, angle 1 and angle 2, right? They would be supplementary. Okay, and this linear pair, angle 1 and angle 2, is not really any different than what we see here with angle BID and angle AID, right? Those two angles would also be supplementary, just like the linear pair we saw here in this crappy example that I drew. Okay, so when you hear linear pairs, right, we're talking about two angles formed on basically a line. By technically, you could still call this a transversal. It's just not cutting through this to make a pair of vertical angles. Okay, because remember, vertical angles, we have four angles that share one vertex. Okay, so moving into the rest of this, lines, transversals, and perpendicular lines, right? So looking at this conjecture right here, okay, if we have a line, so a line M, we're told, right, being cut by a transversal T, so looks pretty familiar, right? And it's forming angles A, B, C, and D, right? Well, if A and B and C and D are equal, well, is it true to say that M and its transversal T must be perpendicular? Well, let's think about that for a second, right? So we know on a pair of vertical angles, their sum is always 360. So if angle A is 90, we'll just say this is A, and so too is angle B, and so too is angle C, and so too is angle D, right? And they're all four equal, okay? And there's four of them. Well, we know A plus B plus C, right? The four angles plus D, the four angles that form these vertical angles here, they must always have a sum of 360 degrees, right? And if they're all equal, well, duh, if we divide this by 4, right, that means each one of these must be 90 degrees because 90 times 4, right? So this is obviously true, okay? This is obviously true. And our proof, if we actually took a protractor and drew this, our proof would be right there, easy, right in our faces. Okay, that's the only way that all four of your vertical angles could be equal is that the transversal and the line are perpendicular. Okay, and one last set of some definitions that we need to know. Okay, so now we see here we've got two lines being cut by the same transversal. And we see that all three of these are not lines, right? So let's just make a note. L M, and N are not lines, they are rays. Okay? That's because they have a starting point, right? And they don't have an end anywhere in sight. They just continue and continue and continue. Okay, anyway, let's talk about what these words mean really quick and then we'll cut this video. So, corresponding angles. Okay, corresponding angles are angles with the same orientation. Okay, so what do I mean by that? Well, A and E are top left, right? So A and E correspond because they're both top left. We could also say, B and F correspond because they are both top right. And we could say the same about C and G. And I mean, you get where this is going, right? So what is D's corresponding angle? Well, D's corresponding angle would be H, right? So now let's talk about interior angles. Okay, so this one's pretty easy to understand. Interior angles are literally the angles inside. That's what interior means, right? So interior angles would be C, D, E, and F. Okay? Because they're inside. Right here, right? We're within, we're inside. Okay, that's the best way I can put it to you. And then you have kind of the opposite, exterior angles. Well, that means these guys on the outside, exterior, those are exterior angles. Okay, so very simple, right? So just a whole bunch of definitions in this video, but all the same, shoot me an email if there's anything you're not sure about, or if you just have any other questions. Goodbye.